So we are starting our MCA program MCS 021 data and file structure block 2. Today we are starting block 2, that is unit, the starting unit is 4 from this block. So the topic is stack. Unit 4, stacks. So in this unit we will discuss first part 4.0 introduction to stacks, then 4.1 the objectives, and 4.2 abstract data type stack, and 4.3 implementation of stack. Two types of implementation that we are discussing, that is 4.3.1 implementation of stack using arrays and implementation of stack using linked lists. Then 4.4 algorithmic implementation of multiple stacks. Then 4.5 the applications of stacks, then the summary, solution answers, then further readings. These are the things in your unit for stacks. So we are moving one by one. So in this presentation I have used only the things from your text. I copied the portions from the text to this presentation. So those who have the text can open it. You can open the block, that block, and that this unit 4 starts. Okay. Then first part, what is stack? A stack is a linear structure in which items may be inserted or removed only at one end. That is called top of the stack. So a stack is a linear data structure, then in which items may be inserted or removed only at one end, and that one end that we call it as top of the stack. For example, we can say all of we are familiar with the CDs that are available in the market. For example, if we are purchasing a 25 CD pack, then the bottom portion is like this, and in the middle portion you can see a stick like part like this, and we are inserting the CDs or removing the CDs from this end only, because this is a closed part with a plastic shield like this. So when we are inserting the first CD through this portion, then what will happen? That will move down and it will be kept here. Then again we are inserting the second CD. We can only insert the second CD, or we can insert from the top. We are inserting the second CD, and that will be above the first one. Again we are inserting, that will be above that one. Like this we can insert CDs like this. Okay. This is the way that we are inserting the CDs in this CD pack. Then the capacity of the CD pack is 25. That means we can insert a maximum of 25 CDs in this rack. And when we are taking out the CDs from this rack, we can only take it out from the top of that CD pack, right? That means the CD that we inserted last can be taken out first. So this is the first CD. This is the first CD that we have inserted. 2, 3, 4, 5, 6, 7, 8, 9 CDs that we have inserted. Then we are giving the numbers like this. And when we remove a CD from this rack, we can remove the 9th CD first. This one that we can remove. This is the 9th CD. We can remove the 9th CD first. So this is the concept of more or less stack. A stack is a linear structure in which items may be inserted or removed only at one end, called the top of the stack. So this is the top of the, here this is the top of the stack. Here this is the top. So when we are inserting, the first one will move down, second one above that, third one above that, like that. And if you want to remove the CDs or items, how is it possible? The last one that we have inserted can be removed first. So in stack, item added last will be the item removed first. In stack, item added last will be the item removed first. Therefore, stacks are also called LIFO. What is the full form of LIFO? Last in, first out. There we inserted the ninth CD as the last one. So we can remove that ninth one first. So last in, first out, or FILO, first in, last out. The first one that we can remove as the last one. So in stack, items added last will be the item removed first. Therefore, stacks are called LIFO, that is last in, first out, or FILO, that means first in, last out. So we also call these lists as piles or piles or push down list. Anyway, that we are using LIFO, or last in, first out, or first in, last out. That is the normally we are using. So two operations are associated with the stacks named push and pop. In this stack, we are using mainly two operations. The first operation that we are using is push, and the next one is pop. Then we are discussing what is push and what is pop. Push is an operation used to insert an element at the top. Then what is push? Push is an operation that we are doing with this stack. What is that? That is inserting an element at the top. We can insert the element only through one end, and that end is called top of the stack. So push means inserting, pushing. Push is an operation used to insert an element at the top. Then pop. Pop is an operation used to delete an element. What do you mean by pop? Pop means delete an element that is also from the top. That is the specialty. Push and pop operation that we are doing with this stack is through only one end, that is the top of the stack. So pushing means inserting elements into the stack. Pop means removing elements from the stack. We are doing both these operations through one end, and that end is called the top of the stack because the other end is closed, that we already discussed. Then how we can do this insertion or push operation with the stack. For example, we have a list of elements. The elements are element A, element B, and element C. These are the elements that we want to push into the stack. The elements are A, B, C. So when we are inserting elements, or when we are saying something about this stack, initially top contains 0. What is this top? Top is the place where we are inserting and deleting, or we are pushing and pushing and popping elements to this top of the stack. So when we are implementing this stack, this push operation, initially top contains 0. Here you can see that this is the top. For example, this is the top. Top contains the value 0. And here we are also using an array. So top of 0. So top contains 0 implies that the stack is empty. So how we can identify that the stack is empty? When the top value is 0, then we can identify that this stack is empty. Means this is empty means no element is inside the stack. The list contains 3 elements. This is the list. So the elements are ABC. The elements are ABC. We want to insert these elements into this stack. Okay. Then push operation. So from this is the list. From this list, first we are inserting the element A into the stack, or we are pushing the element A into the stack. We remove an element A from the list. We remove an element A. This one A from the list. From the list of elements and push it on to stack. Push it means inserting it into the stack. So the value of top before inserting an element, what we want to do, we want to increase the value of top and it become 1, pointing to the what is this 1 represents? It represents the location of the stack at which A is stored. So what is the value of top? That place the new element will be stored. So what is the value of this top where the new element will be stored? So 0 means top 0 means what? 0 means nothing is inside the stack. 0 means nothing is inside the stack. When we are inserting an element or we are pushing an element, first we want to do, what is the first thing that we want to do? We want to increase the value by 1, value of top by 1. So initially the value of top equal to 0, and before pushing the first element we want to increase the value of top by 1. Now the value of top is 1. So in that location, the value of top becomes 1, pointing to the location of the stack at which A, that means the first element, is stored. So first we want to increase the value of top. Here also the value of top becomes 1. So in that location we can insert the element from the list. We want to remove the element from the list and we can insert it to the stack. Okay. When we are inserting something, the first element will be moved down. So the first element that we inserted will be moved down to the stack. Okay. Then this is the after inserting the first element, this is the position. So similarly, we remove the elements B and C from the list one by one and push them onto the stack. So one is already inserted, and next step that we want to insert for pushing the element B to the stack. What is the next step? First step is we want to increase the value of the top by 1. So now the value of top is 1. Before inserting, we want to increase the value of top by 1. That means top of here, top of 2. The pointer is now here. From here, the pointer will move to here. So we can insert the value from the list. Next value in that list is B. So we can insert it here. So we inserted or pushed the value B. Then also in that same way we can insert the value of C also from the list. We can also push the value C to this stack. For that, what we want to do? First, we want to increase the value of top by 1. Now the value of top is 2. So we can insert the value. We can increase the value. Sorry, we can increase the value of top by 1. That is 3. And in now top is 3. And the pointer is pointing to this location. And we can, this one we already inserted. And now we can insert this also. So according the value of the top is increased. So similarly, we remove the element B and C from the list. Remove the elements B and C from the list one by one and push them onto the stack. Accordingly, the value of the top is incremented. So first we want to increase the value by 1, and in that position, in that location, we can insert the new element. Then after that, again we want to increase the value of top by 1, and in that position we can insert the element from the list. So the top now contains the value. What is the value of top right now? The value of top is 3. Here also 3 contains a value 3 and pointing to the location of the last inserted element. Now the pointer is pointing to the last inserted element, that is C, inserted element C. So this is the operation that we can do with the stack. The first operation that we can do with the stack is push operation. So I think it's clear. Now we are moving to the next operation, that is pop. What do you mean by pop? Pop means deleting an element from this stack. So now again I am repeating this thing over here. So now the values or the elements in this stack are A, B, C, and top is pointing, the value of top is now 3 and it is pointing to the element C. So this is the stack after we push the 3 elements. Since only the top element can be removed from the stack, so insertion and deletion are possible only through one end. That end is called the top of the stack. It is not possible to remove the insert the elements from one end and remove the elements to other end. It is not possible. So since only the top element can be removed from the stack, we remove the top element C. We have no other choice. So the last element that we have inserted can be removed first. So from this stack, if we want to pop an element, the element that we can pop is only 3, means the location 3, and the element is C. So since only the top element can be removed from the stack, we remove the top element, that is C. Then C goes to the list of elements and the value of the top is decremented by 1. Now we are popping the element. That means we are popping the element C from here. Popping the element C from here and we are keeping it in the list. So what will happen? The value of top will be decremented by 1. So what is the value of top now? The value of top is now 2. Then the top now contains the value 2 pointing to the element B. Now it is pointing to B, the top element of the stack. Now the top element of the stack is B. Similarly, we remove the element B. So here also we can remove the element B, and want to decrement the value of top by 1. And we are keeping the element B over here. Then similarly we remove the element B. Then after that we are removing the element A from the stack and keeping it in the list. So the value of top become decremented by 1 and it now the value of top is 0. Okay, the value of top is decremented accordingly. I think it's clear. So two operations that we can do with this stack. First one is called push operation and the second one is called pop operation. Push and pop operations can be done through only one end. That end is called the top of the stack. And when we are pushing, first we want to increment the top value by 1. Initially, the value of top should be 0. 0 means the top value, 0 means what? The top value 0 means the stack is. Now the value of top is 0 means what? Means the stack is empty. Then first we want to, for pushing, before pushing that we want to increase the value of top by 1, and in that location, what do you mean by the value of top become 1? It means in that position the new element will be inserted. The inserted element position is the value of the top. So first we want to increment the value of top by 1, and in that location the first element, that is A, will be inserted. Then after that we want to increase the value by 1, and in that location we can insert the second element, and also again we want to increase the value of top by 1, and in that location we can insert the next element. This is the push operation. The next one is the pop operation. Push and pop operation, already we discussed that we can do it only through one end. That end is called the top of the stack. So in pop operation, what is the element that we have inserted last will be removed first. So we have inserted the element C last. So we can remove the element C first. First we want to remove the element C, then decrement the value of top by 1. So now the value of before popping, the value of top will be 3, and we are removing the last element, that is C, from the stack and keep it in the list, and want to decrement the value of top by 1. So now the value of top becomes 2, and it is pointing to the element B. And again we are removing the element B from the stack and keeping it in the list, and decrement the value of top by 1. Now the value of top is 1 and it is pointing to the element A, and now we are removing the element from the stack and keep it in the list, and decrement the value of top by 1, that means 0. So in stack the value of top equal to 0 means the stack is empty. I think it's clear. Now there is no upper limit on the number of items that may be kept in a stack. So there is no upper limit on the number of items that may be kept in a stack. So that means we can insert as much element that we require, or as much element that we need. But some problem is there. However, if a stack contains a single item and the stack is popped, I will discuss it. However, if a stack contains a single item, so for example, the elements that we pushed are A, B, C, and we removed the element A and B, removed the element C and we removed the element B. Now, the stack contains only one element and that element is A. So, if a stack contains a single item and the stack is popped, for example, so this is the stack and now we have only one element, that is A, and the value of top become, now the value of top is 1. So if a stack contains a single item and the stack is popped, popped means removed the element from the list. That means the element A is removed from the list and the value of top become 0. Means what? So if a stack contains a single item and the stack is popped, the resulting stack is called, what is this? The resulting stack is called now empty stack. How we can identify that the stack is empty? We can identify that the stack is empty when the value of top becomes 0. So the pop operation cannot be applied to such stacks as there is no element to pop. So again we are trying to pop Pop means what? Pop means removing an element from the stack. So it is not possible to remove, or it is not possible to pop an element from an empty stack. We know that. So the pop operation cannot be applied to such stacks as there is no element to be popped. So whereas the push operation can be applied to any stack. We can apply the push element to any stack. For example, if the stack is empty, there is no problem. We can push as much element that we require. So this one, there is no upper limit on the number of items that may be kept in a stack. But if we are using an array, we will discuss the implementation array and linked list implementation of stack. So if we are using an array for implementing this stack, then the upper limit is there. One upper limit is there. Why? Because before using this array, we have to specify the size of the array. We can't increase or decrease the size of the array while we are using it. So that we know. We already know that. So there is no upper limit on the number of items that may be kept in a stack if we are not using array implementation. If we are using the linked list implementation, then there is no upper limit. Okay. Then abstract data type stack, again we are discussing it. It's the order. It's the order that is in your text. So we can perform several operations that involve a stack. Start a new stack. So the operation that we can do with the stack is, first one, we can start a new stack, or we can create a new stack. If we are using array implementation, then before starting this stack, we have to declare the array. So that is start a new stack. Then place new information on the top of stack. Place new information means we can insert new elements into the stack. Place new information, or we can place new elements into the stack. Then take the top item of the stack. So place new information onto the stack means what? That is push. Then take the top item of the stack means we can pop. Read the item on the top. So we can traverse. So we can read the elements in the stack. Then determine whether a stack is empty. How we can identify that the stack is empty? The value of top is 0. Then we can identify that the stack is empty. So determine whether a stack is empty. So these are the operations that we can do with this stack. Then implementation of stack. So stacks may be represented in the computer in various ways, usually by means of list and array. So stack may be represented in the computer in various ways. Usually we are using an array or one-way list. So each approach has its own advantages and disadvantages. If we are using an array, it has its own advantage, and also it has its own disadvantage. And also if we are implementing this stack by using list, it also has its own advantages and disadvantages. So a stack is generally implemented with two basic operations that we already discussed: push and pop operation. What do you mean by push? Push means inserting an element into the stack, and pop means deleting an element from the stack. So push means to insert an item onto the stack, because I removed the strike out the things below that, because that is in the next slide. So we are implementing the push operation. Push means to insert an item onto the stack. So the push algorithm is illustrated in figure 4.3a. This is the figure 4.3a, that is also in your text. Algorithm to push an item onto the stack. Just I paste the copy the part and paste it here. So the push algorithm, this is the algorithm is illustrating in figure 4.3a. Here TOS is a pointer. So TOS, top of stack. So TOS is a pointer which denotes the position of topmost item in the stack. So stack is represented by the array ARR. So by using, here we implement this by using an array. The name of the array is ARR. and the max stack represent the maximum possible number of elements in the stack. Why? In the previous slide that we discussed that no upper limit on the number of items that may be kept in a stack, but here we are giving an upper limit. Why? Because we are using this array implementation by using stack implementation by using array. So that's why when we are declaring an array, we should have an the size of the array, that is the upper limit. So here we are using three variables. The first variable is TOS, that's a pointer. Then that represents the position of the topmost item. Then we used an array named ARR. This is an array of size max stack. What's the size of this array? The size of this stack, array is max stack. Why we are putting in max stack? STACK. So why we are putting it in capital letters? Because this max stack, when we are writing C programs, this max stack is a constant. How we can define a constant in C? We can define a constant in C by using the hash define directive. So when we are declaring a constant, normally we are using capital letters. For example, hash define pi, pi 3.14. So we are using this pi in capital letters. Okay, fine. So the variable that we are using in this algorithm are TOS and max stack, and the array we are using in it is ARR. So first step, we are not starting and ending by using the steps. In the first step, check for stack overflow. Then what do you mean by stack overflow and stack underflow? What do you mean by overflow? Overflow means now the maximum size we are using the max. For example, we are using the value of max stack equal to 3, and TOS, top of stack, is also 3. That means what? In the beginning, we know that top equal to, or here we are using the TOS. TOS equal to 0 will be 0 in the beginning. Before that means the stack is empty. Then after inserting or before inserting the first element, we want to increase the value of top TOS by 1. So the maximum size, so for example, max value equal to, what is the value of max value? What's the use of this max stack? Max stack is the size of the array. For example, we are initializing it with the value 3. So in the beginning, TOS equal to 0 means top of stack equal to 0 means the stack is empty. Then before inserting the first element, the value become what? Increment by 1, and now the value of TOS equal to 1. Again we are inserting the next value. Before inserting the next value, we want to increment the TOS by 1. Again we are inserting, we want to insert the values A, B, C. This is the list. So again we are inserting the value. Before that, we are incremented the value of TOS by 1. So this is the maximum capacity of the stack. So in the first step, you are check for stack overflow. If the value of TOS, now what is the value of TOS? TOS is 3. And what is the value of max stack? That is also 3. So if TOS greater than or equal to max stack, that means what? The maximum capacity of the stack is now filled. We can't insert, we can't do a push operation. It is not possible to do a push operation. So first we want to check the stack is full. That is checking for stack overflow. That we call it as overflow. It's full. So if TOS greater than or equal to max stack, that means what? Now the stack is full. So we can't insert or we can't push, we can't do the push operation. Then what we want to do? Display a message, the stack overflow or the stack is full. And what we want to do? go to step 4, or we here it's directly put exit or and go to, normally we are writing algorithm like this, go to step 4. So if the stack is not full, that means first time we insert before insert the max stack equal to 3 and TOS equal to 0 initially, and we inserted the first element. For example, this is a stack. We insert the first element, that is A. Now, before that, the TOS point to TOS incremented by, and it will point to the first position. Again, we are inserting one more element. Before that, we want to increment the value of TOS by 1. Now the value of TOS is 2. We inserted the second element, that is B, and here we can insert one more element. The space is there. So now what's the value of TOS? Now the value of TOS is equal to 2. So again we are checking if TOS, that is 3 greater than or equal to, 2 greater than or equal to 3. The condition is false. So what will happen? It will move to the next step, that is step 2. Increment the pointer value by 1. So TOS equal to 2 TOS plus 1, that is 3. Then increment the pointer value by 1, TOS equal to 2 TOS plus 1. Now the value of TOS is 3, and insert the item. What is the item that is left? C is the item that is left. So we remove the item from the list and push it in the stack. So ARR of TOS means ARR of 3 equal to value. What is the value? C is the value. So we insert. So this is the implementation of stack push operation, the algorithm of push operation. I think it's clear. So now we are moving to the next step, that is pop operation algorithm. The pop operation, all of you are familiar with what is this pop operation? Yeah, it's remove the topmost item from the stack. Why the topmost item? Because we can push and pop the stack through only one end, that is called the top of the stack. So the last element that we are inserted can be removed as first element. So the topmost item from the stack can be removed first. So the pop operation removes the topmost item from the stack. After removal of topmost value, TOS is decremented by 1. So this is the algorithm. First step, check whether the stack is empty. That is the first step. We know that when the stack become empty because when the TOS equal to 0, then the stack become empty. So first we want to check whether the stack is empty. How we can check? If TOS equal to 0, not equal to 0, but if we are using if in C, because it is an algorithm, so we can use equal to. So if we are implementing it by using a C program, then you have to use if, then put a bracket, then TOS equal to 0. Okay, you know that. Okay, so if TOS equal to 0 means what? This stack is empty and there is no possible pop operations are allowed. So first we want to check the TOS equal to empty. Then if so, then what we want to do? We want to print a message, that is stack underflow. The first step, or in push, what we used? We used, that is overflow. Here we are using underflow, or we can use stack is empty and go to step here, return value. Oh, here there is no step 4. So we can write this step 4, exit or end. Go to step 4. Or you can directly write the exit over there. Then if the topo stack is not 0, so we'll just explain. This is a stack. The TOS, first time the TOS equal to 0, and we want to insert the first element A into the stack. So that we want to increment the top by 1. Now the value of TOS equal to 1. Now we inserted the value A over here. Then again we want to insert one more element. So we want to increment the top of stack by 1. Now it's 2. We inserted the element B over here. So this is the state of the stack right now. So if TOS equal to 0, no, TOS equal to not 0, then it will move to the next step. Remove the topmost item. Now what is the topmost item? B is the topmost item. Remove the topmost item. So that we are using a variable value and keep the topmost item into that variable, that is value. Here ARR of TOS means TOS equal to 2, ARR of TOS equal to, now the value of value become B. Then what we want to do? TOS equal to TOS minus 1. Now the value of TOS equal to 2, and after this statement what will happen? The value of TOS become 1. So the position is, the pointer is pointing to this location. TOS equal to TOS minus 1. Then step 3, return the item of the stack. What was the item that we want to return? We want to return the item that is value. What is inside value? B is inside value. So we will return the value B, and the pointer will point to the next element, that is A. We already discussed that it's not possible to remove an item from memory, but we can overwrite it. We can point to point to A, but B will be over there. B will be over there. We can overwrite it. Okay, that is a memory representation I am talking. Then return the item of the stack by using the return value function, and the value now we have in the variable value is B. Okay. So this is the implementation of pop operation by using array. So I think it's clear. Now implementation of stack using arrays. So a stack contains an ordered list of elements. So what is stack? Stack is contains an ordered list of elements, and an array is also used to store ordered list of elements. Hence, it would be very easy to manage a stack using array. So stack is an ordered list of elements. Array is also can store an ordered list of elements. So it is very easy to manage stack by using array. However, the problem with an array is that we are required to declare the size of the array before using it in a program. All of you are familiar with that. So we are required to declare the size of the array before using it in a program. Therefore, the size of the stack would be fixed. That is the problem. The size, that is the demerit of implementing the stack by using array. Size of the stack would be fixed. Though an array and a stack are totally different data structures. So that's why this array and this stack is different, totally different data structures. An array can be used to store the elements of stack. We can declare the array with a maximum size large enough to manage a stack. Program 4.1 implement a stack using an array. Now we are moving to a program, C program, that will explain how we can implement this stack by using an array. So I will discuss, we can discuss it. It may take some time, but we will discuss it, and the next implementation you have to go through it by using your text. That is there. All the programs are there in your text. So now we are discussing a program, the program implementation of stack using array. So all of you are familiar with this hash include stdio.h, all things. So what is this? This is the first line of the C program. Hash include stdio.h means what? It's a header file. standard input output operations that we are the programs that are written in this standard stdio.h header file. So we want to include the header file if we are using any standard input output operations in our C program. Standard input output operations means if you want to print something, that is a standard output operation, and if you want to input something, or if you want to collect something by using this keyboard or mouse, then that is the standard input operation. Okay, so we are using both these things in, I think, almost all of the programs. So we have to include the header file hash include, including a header file that we can use the directive hash include. Then within the less than greater than symbol, we are using the name of the, we are writing the name of the header file, that is stdio.h. Okay. Then int choice, what does this mean? We are declaring this much of variables, the data type of that variables, all the variables data type is int. So int choice, that is one variable. Stack of 10, what is this? It's an array variable. The maximum size of this array variable is 10, and top top. All of you are familiar with top. What is that? This is the pointer to specify the top of the stack. Then element. What is this element? Element means the element that we are inputting or pushing or popping. That is the element. So int choice. So this is a menu driven program. This program is it's a menu driven program. It's not written by myself. It is from your text. I just copy paste it. Just take the screen area by using the screen capture and put it here. Okay. Then if you have the text, you can open it. I don't know the page number. You can just, if you have the block 2 text, that is unit 4 stack, then you can just open it. Okay. So now we declared 1, 2, 3, 4 integer type variables. Then below that, we are using, this is in this program we are using a function called menu. Also we are using a function called push. Also we are using a function called pop, and we are using a function called show elements. So before that, before the function definition, we are using the function declaration part. Okay, all these functions are void type, means what? From this function nothing will return. So we are using the return type as void. I think all of you are familiar with these things. So below that we are writing the void main program. What do you mean by void main? This main program indicate that the program execution will begin from this main. All of you are familiar with this. So the execution will start from here. So void main. Then after that we want to put an open brace over here. It's already there, like this. Then choice equal to element equal to 1 means what? Choice equal to element is equal to 1 means choice equal to 1, element equal to 1. What is this choice and element? These are two integer type variables. So we are initializing it with the data value 1 with both the variables. It is possible in C. Choice equal to element equal to 1. It means choice equal to 1, element equal to 1. Then TOS equal to 0. All of you are familiar with that. The TOS. What is that? Top of the stack. That is top. This is not TOS, but it's top. TOP. Top equal to 0 means it's represented the stack is empty. Then after that menu, we called menu. So when the compiler see this menu function, what will happen? It will move to the function definition part. This is menu, void menu. So it will print. I already told you that this is a menu driven program. All of you are familiar with this menu driven program. Okay. Then enter one of the following options. Then after that it will print the message, enter one of the following options. /n means after printing it, the pointer will the cursor will move to the next line. So push, first it will print push, capital letter push. It will print push. Then it will put a space and print this 1. Then what is that? In the same line we used we are using one printer for printing all the menu items. So push 1, then slash n means the cursor will move to the next line, then after that it will print POP, then again it will put a space and print 2, then again slash n, control will move to the next line, and next line it will print show elements. Only one program I will explain because it will take much more time for explaining this program. Then after that it will print 3. I am printing it down because this is the control part. Okay, then again what will happen? It will slash n is there, then the cursor will move to the next line. There you can see exit 4. Then slash n means it will move to the next line. Okay. So this will print and enter one of the following options. It will print over there first line, and after that it will print this much of elements and scanf %d ampersand choice. %d means scanf is used for collecting some data from the user. %d means here we are collecting an integer type data. So we used %d. Then what the integer data that we entered by using the keyboard will store to the variable choice, that is ampersand choice. What is that ampersand symbol? It is address of operator. So it will store the value to the correct memory address, that is ampersand choice. Then it may be 1. The value of choice may be 1 or 2 or 3 or 4. So according to the value of choice, the program will direct to different functions. Okay, so if choice equal to 0, that we discussed in the algorithm part, if we are using choice equal to 0, that means if you are checking it, the value of choice equal to 0, if we are asking or if we are checking it by using the if statement, then we should use the equal to function, equal to operator. So if choice equal to 1, then what will happen? Here we can convert this by using the switch statement. All of you are familiar with switch. So if choice equal to 1, then what will happen? If we are giving push, if you are wish to enter some data into that stack, then we will give the choice as 1. So what will happen? It will direct to the function push. Then after doing this push, the last statement of the push function is return. Then what will happen? It will return to where? This menu, return to here. It will return here, and after that what will happen? Move to the next function. Here we use the function menu function. Again it will move here and it will print the menu part once more. Okay, if the choice equal to 2 means what? We want to remove an element from the list, from the stack, then we should use the choice number 2. So if the choice equal to 2, then it will call the pop function. Then after return from the pop function, it will again move to the menu here, and it will again display the menu. Then if choice equal to 3 means what? Show elements. So it will print the elements. What are the elements in this stack will be printed by using the show elements function. After printing, it will move to the, it will return, we can see the return over here, I will explain. And when the return function reaches, it will move after this show elements function. So that is, again it will call menu and here. So 4 means we are not mentioning the program for 4 or exit 4. There is no need. So if the choice is not 1, choice is not 2, then choice is not 3, then it will automatically exit the program. So then the first part, that is, if you are using the option or choice as 1, means push. So choice equal to 1, it will call the function push function. This is the data this is the function call. So when the function calls occurs, then what will happen? The function definition part, the control will move to the function definition part. So this is the function definition of push function. Then the maximum value of the stack here we declared as 10. So we can store a maximum of 10 elements in the stack. Maximum element is 10. So we are using array, so it will start by 0 and up to 9. So that we know. So if TOP, what is the TOP? Top means the top of the stack less than or equal to 5. That means the stack is not full. That is top less than or equal to 9. Print we are using, for example, we are using first time we are using this program, and we can initialize this TOP, this right TOP. What is the value of TOP initially? TOP equal to 0. So the value of TOP equal to 0 means what? The stack is empty. So TOP means 0 less than or equal to 9. Yes, 0 is less than or equal to 9. So it's less than 9. So it will enter into the enter here. So print enter the element to be pushed to stack. Then what will print? It will print this message. Enter the element to be pushed to stack. Then /n means it will move to the next line. Then scanf %d ampersand element. We are entering, so we can input only what type of element over here? %d. We can input only integer element. So here we are inputting the value 10 over here. So now the value of ampersand element, the element is 10. So stack of top, what's the value of top now? That is 0. Already we initialized the value of TOP equal to 0. TOP equal to 0 means what here? 0 is the first element. So when we are writing the programs, we are normally using TOP equal to -1. Then after that, before inserting the first element, we will insert top plus plus. We will increment the top by 1. Here it is in your text, it is directly initialized that it is 0. So top TOP equal to -1 means it is empty. So TOP equal to 0 means, all of you are familiar with this, the array is starting from 0 to n-1. So that is the first value. So TOP equal to 0 means the pointer is pointing to the first element in that array. Then TOP of stack equal to element. So here it will printed the value 10 over here. Then plus TOP means it will point, the value of TOP will increment by 1. Now the value of TOP equal to 1, it will point to here. Then else means what? TOP, yes. ചോദിച്ചോളൂ. സീറോ ഇനിഷ്യലൈസ് ചെയ്ത് കഴിഞ്ഞാൽ സീറോ, അതെ നിങ്ങളുടെ ടെക്സ്റ്റിൽ ഞാൻ പറഞ്ഞില്ല, ടെക്സ്റ്റിലുള്ള ഞാൻ അതുപോലെ ഇങ്ങോട്ട് കോപ്പി ചെയ്തതുകൊണ്ട് ഇങ്ങനെ വരുന്നത്. പക്ഷേ TOP ഈക്വൽ ടു 0 നമ്മൾ കൊടുത്തു കഴിഞ്ഞാൽ ഇത് സ്റ്റാക്ക് എം ഡി ആണോ എന്ന് നോക്കാൻ വേണ്ടി പറ്റില്ല, ഇങ്ങനെ വെച്ചിട്ട് പറ്റില്ല. സ്റ്റാക്ക് എം ഡി ആകുന്നത് എപ്പോഴായിരിക്കും? TOP -1 വെച്ച് പ്രോഗ്രാം എഴുതുമ്പോഴായിരിക്കും. പക്ഷേ നിങ്ങളുടെ ടെക്സ്റ്റിലുള്ളത് നിങ്ങൾ റെഫർ ചെയ്യുന്ന ടെക്സ്റ്റും ആയതുകൊണ്ട് ഞാൻ അതേപോലെ കോപ്പി ചെയ്ത് വെച്ചേക്കുവാണിത്. ഇപ്പം മനസ്സിലായല്ലോ എന്തുവാണ് TOP -1 വേണോ 0 വേണോ എന്നുള്ളത് മനസ്സിലായി. എന്താ കാര്യം? ഇത് നമ്മൾ അറേ ഇംപ്ലിമെന്റേഷൻ വരുമ്പോൾ അറേ ഇംപ്ലിമെന്റേഷന്റെ ഫസ്റ്റ് വാല്യൂ എന്ന് പറയുന്നത് 0 ആയതുകൊണ്ട് നമ്മൾ എന്ത് ചെയ്യണം? TOP ഈക്വൽ ടു -1 കൊടുക്കണം പ്രോഗ്രാമിൽ. പക്ഷേ ഇത് അൽഗരിതം അതേ കണക്ക് അവരിവിടെ എടുത്ത് വെച്ചേക്കുവാണ്. നിങ്ങൾക്ക് കാര്യം മനസ്സിലായി എന്ന് വിചാരിക്കുന്നു. അപ്പം -1 വെച്ച് കൊടുത്തെങ്കിലേ എം ഡി സ്റ്റാക്ക് ആയോ എന്ന് നമുക്ക് കണ്ടുപിടിക്കാൻ പറ്റുള്ളൂ. അതാണ് പ്രോബ്ലം. കാരണം ഈ പോപ്പ് ഓപ്പറേഷനകത്ത് പ്രശ്നമില്ല, ഇത് അല്ല പിന്നെ പുഷിൽ പ്രശ്നമില്ല. പോപ്പ് ചെയ്ത് പോകുമ്പോഴത്തേക്കാണ് -1 ചെക്കിങ് ആവശ്യം വരുന്നത്, എം ഡി ആണോ നോക്കാൻ വേണ്ടി. ഓക്കെ. So enter the element to be pushed. First element that we have pushed is 10. Now the value of top become increased by 1. That is top equal to 1. So else means what? Already the value of top equal to greater than or equal to 9 means greater than or equal to 9 means the stack is full. So if top TOP less than or equal to 9, else means what? TOP is not less than or equal to 9. It is greater than 9 means what? Stack is full. We can't push an element into the stack. Then what we want to do? We want to return. From here we want to return. What will happen? When this return statement occurs, it will move to the function call part. This is the function call part, push. It will move after the function call part. After the function call part, what is written over here? This is calling another function, that is menu function. Then what will happen? It will move to the menu function definition. Again it will declare choice equal to element equal to 1, top equal to 0. Again it will move like that. Okay. Then stack is full. This is the push operation. Then again we want to move to the next part, that is pop operation, function definition. If we are giving the value of choice equal to 2, then void POP it will call. Then if TOP greater than 0, TOP greater than 0 means what? We can remove an element from the stack. Here also some problem is there. The greater than 0 means greater than -1 or greater than or equal to 0. Normally we are writing the program. Then we are using TOP greater than or equal to 0. Then minus TOP, that will increment the value. Here the value of TOP equal to 1, minus TOP means TOP equal to 0. He removed one element from the stack. Then element equal to stack of TOP. Then what will happen? It will move the it will copy the value of TOP to the variable element. Then pop the element, it will print the element that is popped. Pop the element. What is the value of element now? 10. Then otherwise, what is that? Top greater than or equal to 0, or sorry, top greater than 0. It's not greater than 0 means nothing is there for popping. So it will display the message pop is empty. Then again it will call the return function. Then the last function, that is show elements. If TOP less than or equal to 0, stack is empty. The here they use less than or equal to. Else means what? Something is there in the stack. Then for int I equal to 0, I less than top, I plus plus, or plus plus I means what? We want to traverse the elements and display it. So print %d/n. First element will be printed. Stack of I. What's the value of stack I? 0. Stack of 0 element will be printed. Then it will move to the next line /n. Again. So after the last, up to the last element will be printed. It will be print the last element. So this is the program implementation. It will take so much time. If you are explaining a program, it will take so much time. So we are not explaining other programs. So the size of the stack, this is the explanation. The size of the stack was declared as 10. This one, the size of the stack declared as 10. Then so stack cannot hold more than 10 elements. The main operations that can be performed on a stack are, that we already know, push and pop operation. However, in a program we need to provide two more options, namely show elements to display the element and exit. When we are using a menu driven program, here we are normally using the exit command also. Then show elements to display the push the elements. So show elements will display the elements of the stack. In case the user would like to get out of the program, then he or she can select the option exit. The choice is a variable which will enable the user to select the options. That we already discussed all these things. Select the option from the push, pop, show elements and exit operations. So top TOP points to the index of the free location in the stack to where the next element can be pushed. So element is the variable which accepts the integer that has to be pushed to the stack or will hold the top element of the stack that has to be popped from the stack. So that is the element, that is the use of the element variable. The array stack can hold at most 10 elements. The array stack can hold at most means a maximum of. That is the meaning of at most. Maximum of 10 elements. One can, nothing can show, it's not, okay, it's also possible to make the stack as empty. So 1, 2, 3, 4, like that up to 10 elements. That is at most. Push and pop will perform the operations of pushing the element to the stack, then popping the elements from the stack respectively. That all we already discussed all these things. This is the explanation of that program. Explanation of the program. The next one, implementation of stack using linked list. So when a stack is implemented using array, it suffers from the basic limitation of an array. What is the basic limitation of an array? The basic limitation of an array is we have to specify the size of the array before using it. That is the basic limitation of the array. Its size cannot be increased. Then once it is declared and we are using that array in our program, it is not possible to increase or decrease the size once it is declared. So as a result, one ends up reserving either too much space or too less space for an array and in turn for a stack. So if you are those who are joining right now, or those who are not, give the roll number and names, please do it. You can give your enrollment number, not the roll number like 1, 2, 3 or 10 or 20. You have to specify the enrollment number of yours. It may be 8-digit or 10-digit number like that. Then your full name. Okay, for marking the attendance, I will give directly forward it to the study center and your attendance will be marked over there. So then in the case of a link, so as a result, one ends up reserving either too much space or too less space for an array and in turn for a stack. This problem can be overcome if we implement a stack using a linked list. So in the case of a linked stack, we shall push and pop nodes from one end of a linked list. The stack as linked list is represented as a singly connected list, singly linked list. So each node in the linked list contains the data and a pointer that gives location of the next node in the list. Okay, that we already discussed about this linked list. So singly linked list is there, doubly linked list is there, secular linked list is there. So for array implementation of linked list implementation of stack, we are using a singly linked list, and this singly linked list contains a data part and a pointer part. What is the use of this data part and pointer part? Data part holds the element and the pointer part or the address part points the given location of the next node that we already discussed. So here the program 4.2 implements a stack using linked list is already there in your textbook, and we are not going to explain it because it will take so much time. You can just go through your text program 4.2 and you can just type it and run it in C. So the explanation of that program, program is not explaining here, not written over here. Just we are explaining that program that is in your text. So initially we define a structure called node. In that program we declared a structure by using the type def command. We used or initialized a structure called node, then enhanced. So each node contains two portions that we already know, the data part and the pointer part, that gives the address of the next node in the list. So the push function will insert a node at the front of the linked list, whereas pop function will delete the node from the front of the linked list. Both are possible from we know that from the front end only. So there is no need to declare the size of the stack in advance. Why? Because we are not using array, we are using a linked list. So there is no limit for the size of the stack. So as we have done in the program where we implemented the stack using arrays, since we create nodes dynamically, we creating the nodes dynamically. In linked list we are creating the nodes dynamically and delete them also dynamically. I think you are familiar. We know that what is dynamically and static. dynamic and static. So the function display will print the element of the stack. Here display elements, we use the function by using array, we use the function display elements. So that is the explanation of the program. So here next part, algorithmic implementation of multiple stack. So we can use multiple stack by using array or linked list. So now we have been concerned only with the representation of a single stack. Then what happens when a data representation is needed for several stacks? If you want to insert more than one stack. So let us see an array X whose dimension is M. So the name of the array is M, X, and the maximum size of the array is M. For convenience, we shall assume that the indexes of the array coming from 0, because normally the size of the array or the indexes are coming from 0 to n minus 1. So for convenience, we are using the first element as not the 0th element but the first element, and end at m, not m minus 1. If you have only 2 stacks to implement in the same array X, then the solution is simple. So we are using a single array for implementing what? 2 stacks. So if we have only 2 stacks to implement in the same array, that is the name of the array is X. So if you want to implement 2 arrays by using 2 stacks by using a single array, it is simple. The programming side is simple. Suppose A and B are 2 stacks. We can define an array stack A with n1 elements, and an array stack B with n2 elements. So overflow may occur when either stacks, that is A contains more than n1 elements and B contains more than n2 elements. Then only the overflow occurs. So here, suppose we are explaining it. Suppose instead of that, we define a single array stack with n equal to n1 plus n2 elements for stack A and B together. So the previous slide we are using, suppose A and B are 2 stacks. We can define an array stack A with n1 elements. So one array is A for what? For implementing the stack A, and another array. So A with n1 elements and an array stack B with n2 elements. So implementing the stack B, we are using another another array. Means here we want to implement 2 stacks by using 2 arrays. So here, suppose instead of that, means we are using 2 arrays for implementing 2 stacks. 2 arrays for implementing 2 stacks. Instead of using 2 arrays for implementing 2 arrays, we define a single stack with n1 equal to n1 plus n2 elements of stack A and B together. So that means we are using the array A and B together for implementing the stacks A and B. So here I will explain. See figure 4.4 below. This is the figure 4.4. Let the stack A grows to the right and stack B grows to the left. In this case, overflow will occur only when A and B together have more than n equal to n1 plus n2 elements. So it does not matter how many elements individually are there in each stack. So simply we can explain that this is we are using one array. This is an array for implementing 2 stacks. First, the name of the first stack is A and the name of the second stack is B. For implementing stack A and B, we are using how many arrays? We are using only one array. Stack A grows to the right and stack B grows to the left of the array. So in stack implementation, you are using 1n for inserting and deleting. For pushing and popping, we are using one end. So in the left end, we are using the first stack, that is stack A, and the insertion and deletion or pushing and popping of the first stack, that is A, through this end, that is the left end, and in the same array we are using for pushing and popping the elements of stack B. So how is it possible? So what are the advantages of using this? So overflow will occur only when A and B together have more than n equal to n1 plus n2 elements. What is this n1? n1 is the element of stack A. n1 is the element of stack A. What is n2? n2 is the element of stack B. So we are inserting the first element, or we are pushing the first element of A over here. That is, for example, 10 we push over here. And then what will happen? What will happen? The array will grow. The stack 1 will grow. The stack A will grow from left to right, and stack B will grow from right to left. So we inserted the first element, that is 10 in stack A, and the next element, that is 20 in stack A. Only two elements are there for inserting stack A. And all other elements that we are inserting, for example, 100 over here, and 90 over here, 80 over here, 60 over here, and 50 over here, and 40, 30, 20, and 10, and 9. So now also we can insert one more element. So what will happen? Overflow will occur only when A and B together have more than n elements. So here the capacity of this array is, for example, the array is 20, and in the first stack we inserted only 2 elements. So we can use the 18 element space in stack B. That is the specification, or that is the advantage we are using one array for implementing 2 stacks. So just you can go through this concept. So algorithmic implementation of multiple stacks, just go through this again. So if you have if you want any clarity, you can ask. So this is the concept. Because the stack we are using one end for pushing and popping, in a array we can use both the ends. So one end for inserting and removing or pushing and popping one stack elements, or that is a stack A, and the other end we can using inserting and deleting or pushing and popping elements of stack B. So this is the concept. Then some applications. Stack are frequently used in evaluation of arithmetic expression. Some more portions is there. You can go through that. That I think it's not relevant for an examination. So I just skip it one small portion. So stack are frequently used in evaluation of arithmetic expressions. The stack that we are using for implementing for frequently used evaluation of arithmetic expressions, and arithmetic expression consists of operands and operators. Then Polish notations are evaluated by stack. Then conversions of different notations, prefix, postfix, infix, that I think all of you are familiar with this. Otherwise you will be studied what is this postfix, that is prefix and infix. Then into one another are performed using stacks. Then stacks are widely used inside computer when recursive functions are called. I think you are familiar with this recursive function. What is this recursive function? Recursive function means a function called by itself. That is called a recursive function. So stacks are widely used inside the computer, this implementation of recursive functions. Then the computer evaluates an arithmetic expression written in infix notation in 2 steps. First, it converts the infix expression to postfix expression, and then it evaluates the postfix expression. In each step, stack is used to accomplish the tasks. So when you are writing C programs, if you are starting, for example, printf, like this, printf, and we started the opening bracket and put a double quote, then we want to write or we want to type the things that we want to print, and we forgot to put the closing bracket. So when we are compiling, it will display that this is an error. So this type of errors that we are using this tag for displaying this type of errors, because when we are putting an open bracket, then it will print the first part of the stack. Again, a double quotes, it will print over here, and again the closing bracket, closing quotes, it put over here, and here we want to put the closing bracket, but we forgot to put that. Then the simply it can be identified by the compiler. So there they use this stack there, that is the application of stack over here. Okay, then I think it's enough. You can now the time is 3:30. I think it's the time for winding up. So 10 more styles is there, I already prepared, but the time is now 3:30. So I think we can wind up right now and meet the next class. Those who are not shared your enrollment number and name, please share it right now. And if you have any doubt right now, you can ask about this portions. This one, what is stack, that we already discussed. Then the operations of stack, push and pop, what is it? Then inserting elements and pushing operations, push and pop operations. Then the operations that we can do with this stack, other operations. Then algorithm explanation, push and pop, implementation of stack using array. We well explained the program. Then explanation of that program again. Then implementation of stack using linked list. Program is there. You have to, this one, program is there. Then the explanation of that program. Then multiple stacks by using multiple arrays, and multiple stacks by using single array, or two stacks by using single array. Then the application. So this much of portion that we have discussed and completed. This is the end of this unit, and the next unit is Q, that we will discuss in the next class. Okay, any doubt that you can ask right now? If you have any doubt, then you can ask it right now.